This is part 2 of the Solstice stereo installation. So I've included this to kind of show what I did with the wiring harness so it'll plug right in and work as it's supposed to without any wire splicing. So without any hesitation, let's get to it. Is your basic cheap $200, $220 stereo. I think that's going to work just fine. It runs Android 8 and then along with that you're going to want to keep the steering wheel controls, so you're going to need the steering wheel interface, the chime module, and then an antenna adapter because I think that they use a small antenna there, and then the plastic kit itself to adapt the frame to the existing frame in the Dougie. So those are all the things you need to install, with the exception of the Dougie. Install this stereo and I think we'll call this stuff up. Right? Right. So what we're going to do here is we have this needs to connect here. So, and then what we're going to do is we're going to probably just work on staggering at least half of the wires so that our solder connections, this thing really doesn't need to be very long at all because, you know, that plugged into the stereo as it was and we were able to get it out. So I think what we'll do is we'll just kind of match this up here and then we'll start kind of cutting our wires off and kind of leave some groups of wires, but try not to have all your connections in one spot there. I know it's really tempting because what they do is they strip the ends of these wires. It's almost as if to tell you, here guys, here's what you do. We'll just strip the ends of those wires and pull those off, and we'll put those on and we'll kind of solder them together. Bad idea. Don't do that. I'll show you how to do it right. Okay, we have our first problem. So what happens is that this is a GXP, meaning that it has a premium sound system. It's called the Monsoon sound system. The way I knew this was I looked at the regular production options, RPO codes, in the glove box. It's an amplifier that's in the rear of the vehicle. Takes left and right and front and rear and distributes it out to, amplifies it and distributes it out to a subwoofer, separate tweeters and a mid-range in the front, and then mid-range speakers in the rear. So in studying the wiring diagram, what kind of brought it to my attention is that it has right rear low level audio signal plus, right rear low level audio signal minus, left rear audio signal plus and minus. So low level is 3/4 of a volt peak to peak. You definitely don't want to take power output here and put it into a Monsoon amplifier that wants a low level input. So what we're going to do is we're going to see exactly what they mean. What do they mean by low level input? I'm going to put the stereo back in, then back probe in and see exactly what kind of amplitude we have. And if it's anywhere between, say under a volt, we know that this is an actual low level signal. Another thing we have to be concerned about here is there is a radio turn on signal, which is just a pink wire, and it's provided by the stereo to the amplifier. And also there is a signal called radio control signal. This has speed sensitive volume, meaning that when you drive faster, the stereo can get louder. So this is a PWM signal, a pulse width modulated signal with a different duty cycle. And as the duty cycle increases and decreases, the radio will adjust for your speed. It takes CAN bus serial data and gets the VSS signal right off of the CAN bus, and then is able to control through the stereo, is able to control the amplifier. The head unit will do low level and high level, and it's programmable through the dealer. We're going to see what kind of amplitude we have on our low level outputs coming out of the amp, and we're also going to probe this radio control signal and also this radio on signal, the pink wire. So we'll probe all three of those and we should be able to get this amplifier working as is. Let's back probe and see what we find on the outputs. Here we are back in the vehicle. So the first thing we want to check, right rear low level plus and right rear low level minus. And carefully plug the stereo in. So you can see it's kind of hard to tell, but there's
isn't licensed.
Plus, the Geico Insurance
42
Agency can help
millivolts.
you save on home,
So we're going to
renters,
change
and
the
condo
scale
insurance.
to...
And Geico could help you save on boat, RV, or motorcycle insurance.
Ghost Dog can't help anybody
To
with
peak.
anything. He can hardly handle the paranormal shopping cart he's
We'll go
pushing.
peak to peak. So you can see you've got about half a volt.
And a new 2019
Peak to peak.
Toyota RAV4 from Gresham Toyota.
There you go. There's your 3/4 of a volt right there.
All-wheel drive cap cost $26,769. Total lease charge was $11,770.
Okay, that's low level.
Per year, no security deposit required. Inventory credit.
So that's fantastic. So we found out that the low level output made by this stereo is anywhere from a half a volt peak to peak to 3/4 of a volt peak to peak, which is perfect for a low level input. That's what you need. So we will be taking the speaker outputs from the RCA level inputs out of the stereo and into the amplifier. So that answers that question. So now let's look at this radio on signal. It's pink wire. I suspect this is going to be just like a regular remote turn on wire because it does connect to radio on signal. Okay, pink wire. All right, now we got our back probes hooked up. Well, it looks like the pink wire is 11.25 volts. So we'll just hook that up to switched ignition. Now the last signal we have to probe is the radio control signal. I suspect this is going to be the PWM signal that adjusts the volume according to your speed. So we'll back probe that one. We'll keep the same ground, and then the radio control signal will be a light green wire, pin 15 on C1. Okay.
$279 per month. Come check out the
That looks
all-new
pretty close
huge
to ground. That's
Honda
kind of what we would
Civic with over
expect according to
500
the
new Hondas in
truth table.
stock on the go.
Okay, so the scope, it never lies. So we know that the radio control signal most likely is going to be grounded, and the pink wire will have to be connected to hot. And also, we also know that we're going to be using the low level outputs out of the stereo. Those are the three things we know. Well, we can now build the harness and solder up the harness and plug it in and see what happens. So in taping this harness up, I realized that I wanted to knock a pin out of one of these connectors here. So these things are actually really easy to do. You don't do it from behind. A lot of times you'll get a key, and you'll put it from behind, but actually you go from the front. So in this case, I want to extract this. This isn't used in my harness, and I want to use this pin somewhere else on the connector so I don't have to hardwire anything. So you stick it in the hole right next to the connector, give it a little push, bam, out it comes. Now you can use this pin and put it in somewhere else. In this case, I'm going to put it in for my steering wheel control. That would be pin 14 of the harness, and I have to connect pin 11 of the 14 pin. See, so I can use this wire somewhere else, and then I trace it out, and it goes right here. So I'll just have to make note of that. But this is a 10 volt reference for the steering wheel control. Yeah, there you go. Here's another tip here. So this is the serial data line that goes to this connector. They're spliced together right there. So I need a pin for my steering wheel control signal, which is right next to it. So that's pin 10. So they have pin 9 and pin 10 connected together. This must be for a different application, and where pin 9 and 10 could be the serial data line on either one. So they tapped both of them. So we can extract this one here. Bam, there comes the pin. So we'll put it right next to it. Then we won't have to splice into the wiring harness at all. So that's the last connections we made, and you can see kind of what I've done. I've kind of just taped them up so you can get an idea where they go, and then when you go to, we'll just leave the speaker outputs last. I kind of did process of elimination, got them all taped together. That's the stereo end here, and this is the car end here. And remember, you don't have to splice anything in, so you kind of cut off some wires that you're not using, make sure that they're staggered, then start wiring up your connections. Make sure that you don't have any connections happening in the same spot. This is an IPC manual. So I'm going to go to the section on splices here, and it says it talks about kind of what's acceptable and what's not acceptable. It says splices shall be staggered within specified design limits. It's called a mesh splice. So this is an acceptable. This is kind of what you want it to look like. Most of the splices I make are of this kind. They have they have wrap splices. Then they have, hook splices. There's all kinds of different splices you can do, especially if you have high voltage or very high current connections. What I try to get away from is doing a lap splice. I really don't care for this one up here. You definitely, if you have two tinned ends, there's really nothing you can do as far as putting those two wires together like that. I guess you could wrap it a little bit. People do this, and this is a very solid connection here too, and it looks really good when it's shrink down. So, and this page here shows kind of why I don't like lap splices. What you do is you end up with something like this, and this is definitely it's a defect. You definitely want to strive for that mesh splice. That's going to be your strongest splice. All right, let's start making our connections and soldering this harness up. I need to join these three to that one. Slide that red heat shrink over. And that's how you properly put 4 wires into one. Last connection we have to make is take these speaker wire outputs and connect them to the low-level RCA outputs. Now these are a little bit different as far as how you strip the wiring back, and we'll take Probably just take one of these, make it as long as possible, and then same kind of thing, do your solder connections so you don't have a solder joint in the same place. There's your connection. When I build a harness like this, I'll do a continuity check of the entire harness before I ever go plug anything in and let the smoke out of anything, because, well, that's bad. Pick the second one. So the second longest wire that I cut here, once again, the one without the stripe goes to the center, and the one with the stripe is the shield, goes on the side. Shrink in the center, shrink on the outside. Repeat, repeat until you get all four done. There's our completed harness. So this plugs into the factory connectors. This plugs into the noisemaker. This box here, that's our steering wheel module. Oh, by the way, all these connections have been tested. Every one of them has been tested for continuity with the multimeter. Having the harness in the car, we tested it and found that the backup light isn't coming on. So once again, you back probe into the connector. I think what we're going to do is we're going to put 5-10 feet of wire on this. You have to tap into an electrical connection. Like on this one is the switched hot, so we'll find out where it terminates to a plug. Put that down. You extract this pin, take your insulation off of here, and then you can get your heat shrink down on there. When you make your splice like that, you can slip your heat shrink tubing over there and have a real clean joint. So we don't want any electrical tape on this. This will hold plenty of current for that backup light. So we'll use something like this. That way, once again, this whole harness can be unplugged. Now, for the reverse, I found in the door pillar here, and you're gonna have to measure 12 volts and stick the car in reverse. There's a light green wire that's for the reverse lights, and it's actually 12 volts, and it'll be fine to trigger the backup camera for the stereo. So we'll run a wire over here. We'll splice that in there and tape that up. And here we are back in the car again. So I have all this ready to go. We'll plug these in. Yeah, chime module works. That's good. That's a very good sign. So what happens is that when you first power it up, the steering wheel control needs to see the volume up pressed. And if you can see on the schematic here, the volume up will give you a value of 1.27 k ohms. So that's kind of what that module needs to see in order to initialize itself, or probably programs itself to your vehicle. So it's just a simple voltage divider to figure out which buttons you have pressed in here. So when we turn the key on, we'll definitely hold that button up, and the other module, the chime module, should auto program. So press the volume up, turn the key on. flashing. Red flashing. And then it's a constant red, so that may be a good sign. Plug into the factory antenna here.
Celebration of Mary. There's almost 350
I feel the subwoofer
feet high.
working
A
behind
brand
me.
new statue is expected to be concluded.
Yeah, I'm hearing success. Okay, our steering wheel control does not work for some reason, so somehow this didn't program correctly. There's a red light and a green light here,
argues,
so maybe we'll go through the key on programming process
roughly the
again.
end of World War II. Areas, and at the same time, indoor spaces have become a lot cleaner.
Retained access power also requires the door being opened up in order to shut off. Everything works except for the steering wheel control, so no problem there. We'll go through the programming procedure again. I'll read it again and make sure that I'm not... I kind of released... Maybe I released the button too early. Maybe I didn't release it quick enough, but it's expecting to see 1.27 k ohms. You should see an open with no buttons pressed, and of course if you hit the volume up, you should see a value of 1.27 k ohms. So I'm going to start there. We'll just do a back probe with everything disconnected. Okay, and there you can see on the meter. I don't know if you can see that or not. I've got, with the volume up button, I've got 1.275 k ohms with the volume up. And with each resistor, with each button pressed, the resistance is going to go up. Because you're gonna go through that 1.27 k ohms. Probably just reprogram it. Okay, 2 hours later, I checked the wiring. I've checked. You're supposed to program each of the individual buttons. I can't get the thing to program, so I'm kind of wondering if it's the AWSC1 steering wheel control box on the scope. I'm taking the wires to the input on key 1 and key 2 that go into the radio itself. When I press a button, it looks like there's a pulse train there of some kind on the scope. Looks like it's about a 3.5 volt pulse train, and it changes all the time. So I'm not quite sure what's going on there. It looked kind of like it would be a packet there for a second, but it's really not. So when you go to program it, what you're supposed to do is you're supposed to hit the start button, click the key on identify, hit the button on the steering wheel, nothing happens. Man, that was frustrating. So 3 hours working on something simple like a steering wheel control interface. So what I ended up doing was I downloaded the software for the installer of this program for the firmware, and from what I can tell, that this thing's programmable. However, if it detects the wrong program, it's never going to be able to be programmed correctly. So what you can do is you can download this utility from Access, and you can simply go through all these manufacturers of these decks, because we knew that from the scope that there was packets of data being sent back and forth to this unit, but nothing really was happening on it. So I tried several of the name brands, and then I got this head unit called Magnadyne. Anyway, for whatever reason, I changed it, flashed it, brought it back into here, plugged it in. It definitely works pretty good now. So now what we can do is we can take this harness, get it wrapped up in some kind of either convoluted tubing or some kind of wire loom of some kind to make it nice. All right, okay, we're gonna finish up this harness. We're gonna cut this out of the system. This is that steering wheel connector. I'm gonna use. You can use lots of different things. You can use Scotch, electrical tape, and electrical conduit, the plastic stuff. But I'm gonna use this woven stuff that I have here. This woven braid material with the cloth, with the cloth tape, and then with all these ends that are unterminated here, we're just gonna take and we'll just dip them in some liquid electrical tape to make sure everything's all sealed off well. And then everything other than that is heat shrink, so it should hold up for a while. And then back and forth and tape it up. We're gonna go with that. Throw her in. So that concludes the building of the harness. If you like this video, hit the like down below. I'll be making another video about once a week. And if you like the content on this channel, please subscribe. I'm a new channel. I could use everyone I can get. And just remember this, with some effort and hard work, you can do all things.